Hey there, Algebra 2 students. Welcome back to Miss McGuire's classroom. I'm Miss McGuire, and today we are going to jump right into Unit 2. So welcome to Unit 2, Lesson 1. Don't forget to put your first and last name at the top of your notes, and make sure that you're writing everything down as we go. You want to make your notes as thorough as possible. So today's topic is, I'm going to be introducing you to piecewise functions. We're going to be talking all things piecewise functions this week. Our objective today is I will graph piecewise functions by identifying key features of each function. All right, so let's jump right in. So what is a piecewise function? Well, a piecewise function is a function that has a whole bunch of pieces, to put it into layman's terms. So if you look at this graph right here, this is a graph of the function f of x. Well, f of x has a whole bunch of pieces, as you can see. It's got part of a parabola that starts and then goes off only in that left direction. We've got a piece of a horizontal line here, and then we've got a piece of a line that starts at 2, 2 with an open circle and then heads off in the positive infinity direction for x and y. So this is an example of a piecewise function. It's made up of different pieces of different equations, essentially. So as we're talking about piecewise functions, keep that in mind. So a piecewise function is defined by two or more rules. So it's defined by two or more rules. There has to be at least two pieces. There can be more than two. There can be 3, 4, 5, however many you want. To decide which rule you need to use, you determine which inequality describes each input value. So piecewise functions come with two or more rules, and then you decide which rule to use based on an inequality. And I'll show you what that means in just a second. Then you will use the corresponding rule. So after you figure out which input value your inequality goes with, then you'll decide which function or corresponding rule to use. So let me show you what that means. So the piecewise function for this graph will be written as f of x is equal to, and then you're going to put the like squiggly brackets. So it's equal to each of these pieces. The first piece is x squared, and then you're going to put a comma, and then x is less than 1. The second piece is just 3, put a comma, for x is greater than 1, but less than or equal to 2. And then the third rule is x, and then x is greater than 3. Oh, and I just realized that the first one should be x is less than or equal to 1. Okay, so I'm gonna now practice with you how to read a piecewise function. So the way that you would read this is f of x is equal to x squared if x is less than or equal to 1, 3 if 1 is less than x is less than or equal to 2, and x if x is greater than 3. So when you see the commas, you're going to read the commas as if. It's conditional. So you use x squared if x is less than or equal to 1. You use 3 if x is between 1 and 2. You use x if x is greater than 3. So let's see how that corresponds to each of these graphs. Well, you can see that our parabola, the graph of f of x equals x squared, starts at this 1 with a closed circle, which means 1's included, and then it goes off towards the negative infinity direction for x and for x, which means it starts with these x values of 1, and then we only include the part of the graph that's less than or equal to 1. For f of x equals 3, well, we have this straight line right here because f of x is equal to 3 if x is between 1 and 2. Well, we have an open circle because 1 is less than x. It's not included. It's not equal to. And then we have a closed circle on 2 because 2 is included with that less than or equal to sign. Then for this line, it starts on, oops, I put that it started on 3, but I meant 2, huh? Let's go ahead and fix that. So this should be x is greater than 2. It starts on a 2 with an open circle because it's not included. And then it increases or goes off towards that x is greater than 2 side, which is off to the right. So I just doodled all over this graph. I'm going to erase those doodles just so my graph is clean and pretty. So this function, f of x, is a piecewise function. It has 3 separate pieces, and you can see through all 3 of those pieces represented in this graph. So let's jump into some other examples. For example 1, we're going to find the outputs given the piecewise function. So for example 1, part A, we have f of x equals 2x plus 1 for x is less than 2. We have f of x equals x squared minus 2 for x is greater than or equal to 2. I guess I could have mentioned that you can either say if or for. So let's go back up here and say if slash for. It means the same thing. You're still using those conditions, so it's all good. All right. So our first input is x is negative 10. Our first input is negative 10. That means we're going to plug in x equals negative 10. Well, which rule do we plug it in for? Is negative 10 less than 2, or is negative 10 greater than or equal to 2? Well, I would say negative 10 is less than 2. Right? So we use 2x plus 1. So to find f of negative 10, you plug it into 2x plus 1. So 2 times negative 10 plus 1. So negative 20 plus 1 would be negative 19. So negative 10 gets us negative 19. Now we're going to do the same thing for negative 1. 0, 1, 2, 3, and 10. So for negative 1, well, negative 1 is less than 2. So again, I'm going to use 2x plus 1. So we're going to have f of negative 1 is equal to 2 times negative 1 plus 1, or negative 2 plus 1, which is just negative 1. Now let's do f of 0. Well, 0 is also less than 2, so I'm going to use that same function, 2x plus 1. So I'm going to have f of 0 is equal to 2 times 0 plus 1. So we get 0 plus 1, which is 1. All right, let's do 1. Well, 1 is also less than 2, so I'm still going to use that first piece of our piecewise function. We're going to use 2 times 1 plus 1, which is 2 plus 1, which is 3. Now what about 2? So we got to do a little bit of thinking here. Is 2 less than 2, or is 2 greater than or equal to 2? Well, I would argue it's the second one. 2 is greater than or equal to 2 because it's equal to itself. So that means we're going to use the second rule, x squared minus 2. So we're going to plug in f of 2 is equal to 2 squared minus 2, 4 minus 2, which is 2. Same thing with 3. Well, is 3 less than 2? No, so we're not going to use the first rule. 3 is greater than or equal to 2, so we're going to use the second rule, x squared minus 2. So we're going to have 3 squared minus 2, which is 9 minus 2, which is just 7. And then 10. Our last input is 10. So to find f of 10, which rule am I going to plug this into? Well, is 10 less than 2? No. Is 10 greater than or equal to 2? Yes. So we use the second rule. So f of 10 would be 10 squared minus 2, 100 minus 2, which is 98. So our output for the input 10 would be 98. All right, so why don't you go ahead and try an example on your own. So for part B, your piecewise function is, this 2 is extra. I don't know why it's there, to be honest. Okay. All right, so your piecewise function is f of x equals -4, for x is less than or equal to -2. It's equal to x minus 2 for -2 is less than x is less than 2. And -2x plus 4 for x is greater than or equal to 2. So for each of these inputs, figure out which part of the piecewise function you need to use, and then find your outputs. Go ahead and give this a shot on your own, press pause, and then press play when you are ready to check your answers. So as you can see, these are all of the outputs I got for the given inputs. I also color-coded my piecewise function in my table, so you can tell which function or which piece of the function that I used to find each output. So to find -2, I used the first one. To find -1, 0, 1, and 2, I used the middle one. And then 3 and 10, I used the third one. And hopefully our answers match up. So for example 2, instead of being given the function rules or the equations, we're given the graph of the function. So we're going to find the outputs by reading the graph. So our very first input is x equals -2. So on the graph, we're going to go to where -2 is on the function. So x is -2, so this would be here. So the point where the x value is -2 is located right here. So this point would be -2. The y value of that point is 4, so -2, 4. That means that the input is -2. Remember, the input is your x values, your output is your y values. So our output would be 4. Let's do the same thing with -1.5. So -1.5 would be about here. And I would say that point is, that y value would be like 2.5. So we'd have an output of 2.5. Well, for 0, the point would be located there at the origin. The y value of that point is 0, so our output would be 0. Then for 1, well, we have a point here and we have a point here. Well, where is the point that has the closed circle? The closed circle is where that point is included in the function. So the closed circle is at 1, 1. So we want that output. Then 1.5 would be here at 1.53. 2. Well, there's a point here that's an open circle and a point here that's a closed circle. Remember, the closed circle means it's included. We want that closed circle for our y value. So 2 would go with 3. And then for 3 as our input, well, we have a point right here on this line, and that point would be 3. There we go. We just found all of our outputs by reading the graph of our piecewise function. So for part B, here's the graph. In your notes, if you are doing this on notebook paper, you do not have to draw this particular graph, but that only applies to part B for example 2. The rest of the graphs you definitely have to do. All right, so why don't you try this out on your own, press pause, and then press play to check your answers with mine. So these are the outputs that I was able to find. It's okay if your decimals are just off by like a 1/10 compared to mine. These are kind of estimates by reading the graph, so that's fine. I got -4 as an input, gives us 2 as an output, -2, -1, -1, 3.5, 0, -1, 1, 0, 2, 0.5, and 5, 1.1. Good work, guys. Now we're going to do the fun part of graphing piecewise functions. So example 3, part A and part B are going to give us 2 piecewise functions that we need to graph. So here are the steps for graphing piecewise functions. Step 1, you're going to want to find the endpoints for the very first piece of the piecewise function. So find the endpoint, and sometimes there will be more than one, so we're going to add an S. So find the endpoint for the first piece. Then step 2 is use the endpoint that you found in step 1 and the slope to graph the first piece. Then step 3 and 4 are to do the same things as step 1 and 2, but for the second piece of your piecewise function. So for step 3, we are going to find the endpoint, and I'm going to put S in parentheses because sometimes it'll be more than one, for the second piece. And then we are going to use that endpoint that we found in step 3 and the slope of the equation in order to graph it. So use the endpoint and the slope to graph the second piece. All right. So let's go ahead and try that out. So step 1 is to find the endpoint for the first piece. So our first piece of this piecewise function is this x plus 6, and for x is less than or equal to -4. So we have y equals x plus 6 for x is less than or equal to -4. So if you recall from Unit 1 Lesson 10, I showed you how to find your endpoints and then graph a function based on that restriction on the domain or the range. This is the same idea as that lesson. So we only have one restriction, and that restriction is x has to be less than or equal to -4. So that means we need to find one endpoint. And to find that endpoint, we're going to use x equals -4. We're going to use that restriction. So we're just going to plug in -4 for x into our equation. So then y would equal -4 plus 6 is 2. So our endpoint has an x value of -4 and a y value of 2. Then we need to recognize the slope. So if you look closely at this equation, y is equal to x plus 6. This reminds me a lot of mx plus b form. Y equals mx plus b. My slope is whatever's being multiplied by x. So my slope, well, technically there's a 1 here being multiplied by x, so my slope is m equals 1. But remember, our restriction is x has to be less than or equal to -4. So let's go over here and go ahead and graph. And the first thing we need to do, of course, is label our graph. All right, now that my graph is labeled, let's go ahead and get this graphed. So the first thing I'm going to graph is my endpoint. So -4, 2. So -4, 2 is this point right here. But x, let's see. No, x is less than or equal to -4. So I know that it's included, so I have a closed circle on that point. All right. Now, I want all of the x's that are less than or equal to -4. Well, x is -4 would be here where that yellow line is. All of the values that are less than -4 go off towards that left direction. So I don't want to graph to the right of this point. I want to graph to the left of this point. And since my slope is +1, if I went to the right, I would go up 1 over 1, up 1 over 1, up 1 over 1. So to be able to go to the left, I do the opposite of that. I'm going to go down 1 over 1, down 1 over 1, and move to the left. And then we draw our line, and we put our arrows at the end of that line to show that that line continues forever. So don't forget to add your arrow. And I'm going to erase these yellow things because those are just extra. Okay, now let's do the second part. So 2x minus 4 for x is greater than -4. I'm going to show my work over here. So y would be equal to 2x minus 4 for x is greater than -4. All right, we're going to find our endpoint. And to find that endpoint, we're going to use x equals -4. Because our restriction is x is greater than -4. So whatever that restriction is, we want to use that in our equation to find y. So we're going to have y is equal to 2 times -4 minus 4. So y is equal to -8 minus 4. Y equals -12. So we have a point at -4, -12. And then our slope is m equals, well, what's being multiplied by x, 2. And then x is greater than -4. It's not included, so we're going to have an open circle at this point. Okay, well, first of all, it looks like I need to count differently here. Let's count by 2s. So 2, 4, 6, 8, 10, 12, which means this point, -4, 2, needs to move down 1. Sorry, guys, I didn't go up high enough. All right, so -4, 2 is here. And then our slope is +1, but we have to go down. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1. Here we go. All right, so I just had to shift it down because I had to redo my y-axis so I can make sure I could get to -12. All right. Now, let's do purple. So -4, for our purple line, we want to be at -4, -12, and it's going to be an open circle since x is greater than -4. So we know that it's not included because there's no equal to in this inequality. And then our slope is +2. And I know that all the x's that are greater than -4 are in this direction, the right direction on the x-axis. So I do want to go up 2 over 1, up 2, up 2 over 1, up 2 over 1, up 2 over 1. But remember, I'm counting by 2s on my y-axis, so it looks like I'm going up 1 over 1, but I promise I'm not because I'm really going up 2 since I counted by 2s. All right, here we go. We've graphed our first piecewise function. For example 3, part B, you're going to graph the piecewise function f of x equals -2x minus 1 for x is less than or equal to 2, and -x plus 4 for x is greater than 2. So find your endpoint for each of those, use your slope, and then graph that piece of the line. So go for it, give it a shot, press pause, and then press play when you're ready to check your work. So as you can see, this is the graph of the piecewise function that I found. For the first function, y equals -2x minus 1 for x is less than or equal to 2, I found my endpoint to be 2, -5. I know that x is less than or equal to -2 off towards the right, so I went up 2 over 1, up 2 over 1, up 2 over 1. To ensure that I had a negative slope, I went up to left 1, up to left 1. Okay, Then for the second piece of our piecewise function, y equals negative x plus 4, I found my endpoint at 2, 2. I use the slope -1. And then because x has to be greater than 2, I know that I have an open circle. That point will not be included, that endpoint. So 2 is an open circle. And then my slope was -1, so then I just went down 1 over 1. And I know all of the x is greater than 2 values are towards the right, so I knew that I needed to move in that direction for my graph. All right, that's all for today's notes. You can go ahead and get started on tonight's homework, and I'll see you back in class. Have a great day, guys.